Good morning everyone. Today we are going to see the purpose of database systems. So in the early days, database applications were built directly on top of the file system, which leads to data redundancy and inconsistency. So the data is stored in multiple file formats, resulting in duplication of information in different files. So the difficulty in accessing the data, need to write a new program to carry out each new task. So data isolation, it means multiple files formats, and integrity problems. So integrity constraints become buried in program code rather than being stated explicitly. So here hard to add new constraints or change existing ones. So let's continue with the purpose of database system. In the previous slide, we discussed the problems of traditional file system. This slide explains how a database solves those problems. The first concept is atomicity of updates. So atomicity means that a transaction should either be completed fully or not happen at all. For example, imagine transferring 5,000 from one bank account to another. The amount should be deducted from the sender only if it is successfully added to the receiver. If the system crashes halfway, the transaction should be cancelled completely. This prevents incorrect data. The next issue is concurrent access. Many users may access the same database simultaneously. For example, during college admission, hundreds of students may register at the same time. If two students try to book the last available hostel room simultaneously without proper control, both might receive confirmation. This creates inconsistency. A DBMS uses concurrency control techniques to avoid such problems. Finally, we have security. Not every user should be allowed to access all the information. For example, a student can view only his or her own marks, while the faculty can update marks and the administrator has complete access. So, database systems provide atomicity, concurrency control, and security, making the data management reliable and safe. So here the university database example. To understand database concepts more easily, we will use a university database as an example throughout this course. A university stores different types of information such as student details, instructor details, course information, classroom schedules, and grades. So the database allows us to perform many daily operations. For example, when a new student joins the college, the student's information is added to the database. When semester registration begins, students register for different subjects and the system automatically prepares class list. At the end of the semester, faculty members can enter the mark into the database and the system calculates GPA and generates mark sheets or transcripts. So view of data. A database contains a huge amount of information. Users do not need to know how all this information is stored internally. Instead, the DBMS provides an abstract view of the data. So the word abstraction simply means hiding unnecessary complexity from the user. Think about using an ATM. When you withdraw your money, you only see options like withdraw, deposit, or balance inquiry. You never see where the data is stored or how the bank updates its database internally. Similarly, in a database system, user only interact with the required information. To organize the data properly, database uses something called data models. A data model defines how the data is stored, how different pieces of data are related, and what rules should be followed. So data abstraction makes databases easy to use while hiding all the complicated internal details. So let's now discuss different data models. A data model is simply a method of organizing and describing the data. It defines the structure of the database and the relationship between different data items. There are several types of data models. The most popular one is the relational model, where the data is stored in tables. Another model is the ER model, entity relationship model, which is mainly used during database design to represent the entities and relationship graphically. We also have object-oriented and object relational models which support objects similar to object-oriented programming. Another important model is the semi-structured data model, commonly used for XML documents. Older models include the network model and the hierarchical model, but nowadays they are rarely used in modern applications. Among all these, the relational model is the most widely used because it is simple, efficient, and easy to understand. Next one is relational model. Now let's study the relational model, which is the foundation of most modern database system. In this model, all the data is stored in the form of tables. Each table consists of rows and columns. Columns represent different attributes. For example, a student table may contain student ID, name, department, and age. Each row represents one complete record, so every student occupies one row in the table. This table format is very similar to Microsoft Excel, making it easy to understand. Different tables can also be connected using common fields called keys. For example, the student table and a course table can be connected using student ID. The relational model reduces data duplication, improves consistency, and allows us to retrieve information easily using SQL queries. Thank you.